Alright, Assalamualaikum warahmatullahi wabarakatuh. Hey everyone, here is your teacher again, Mr. Hilman, and today we're going to learn about significant figures. Some figures are just not so significant because of where they stay. Ya, jadi kita sekarang bakal belajar tentang significant figures atau dalam bahasa Indonesia disebut dengan angka penting. Jadi angka bisa penting, angka juga tidak bisa tidak terlalu penting, tergantung di mana mereka posisinya. Alright, uh, is significant figure so important? Yes. Why? Because there's a problem with measurement, and the problem is that they're not all identically accurate. Jadi tidak semua alat ukur itu akurat, ya. I have two examples here. A regular weighing scale has 0.1 kilogram of accuracy, whereas a kitchen scale has 0.01 kilogram of accuracy. Jadi penimbang berat biasa itu akurasinya sampai 0,1 kg, tapi penimbang penimbang massa yang di dapur yaitu ketelitiannya, akurasinya itu sampai 0,01 kg. So for the regular weighing scale, it has a tenth kilogram of accuracy, but kitchen scale has a more accurate measuring capacity until 100th kilogram. And does it make any issue or problem? Oh yes. Let's see the example. Suppose there is a person who weighs 72.8 kilogram, but the clothes he is or she's wearing is 1.32 kilogram. Jadi orang ini beratnya 72,8 kg setelah diukur di alat timbangan biasa, tapi setelah ditimbang bajunya tuh menggunakan timbangan yang lain yang lebih akurat, bajunya 1,32 kg. What about his net mass? What is net mass? Net mass is mass of a person without clothes. Kalau gitu berapa massa tubuh asli orang itu, massa bersih tubuh orang itu? Is it 71.48 kg? According to the calculator, yeah, it is 71.48 kg, but no, it's not. It's supposed to be 71.5 kg. Why? As we can spot here, these two measurers are not the same accurate. Yang satu itu sampai 0,1 kg, tapi yang lainnya lebih akurat 0,01 kg. Okay. And we need a fair measurement. Karena kita butuh pengukuran yang adil, maka we cannot choose a more accurate result to 100. We need to back ourselves down and choose the less accurate one. Karena salah satu alat ukurnya itu kurang akurat, maka kita pilih yang kurang akurat. Kita kurang bijak kalau menulis angkanya sampai per 100. Jadi kita tulis sampai per 10 aja, ya. That's why we choose 71.5 instead of 71.48 kilogram. Right? Yeah. So the conclusion here is that we choose the less accurate measure, right? But that's when you use two different measurers. What about if you use only one measurer? A single measurer only for a measurement. In this case, a student measures a physics book with a ruler of 0.1 centimeter accuracy. So this ruler has an accuracy until a tenth centimeters. And after being measured, the student discovered that the book's length is 27.5 centimeters, and the width is 20.2 centimeters. What is the area of its front cover? Jadi kita tahu penggarisnya bisa dilihat di sini, dia punya akurasi sampai 0,1 cm. Dan setelah diukur dapat angka-angka yang ada di layar kalian sekarang ini, 27,5 cm dan 22,2 cm. Dan pengukuran ini dilakukan hanya menggunakan satu alat ukur saja. Jadi berapa luas sampul depannya? Is it 555.5 cm? If you use your calculator right now, the result that will be shown is this, ya, 955,5 cm persegi, 555.5 cm square. And again, it's not correct. Suppose it has to be 556 cm square. Why? Now we only use a single measurer. How can we still have this kind of problem? Satu alat ukur kenapa masih ada masalah? The reason is, although ruler can measure until the accuracy of a 10th centimeter, meskipun penggaris itu bisa mengukur sampai akurasi sampai per 10 cm, but there is no way that we can be sure of that the accuracy of the area can be as good as 0.1 cm square. Tapi masalahnya kita tidak sulit yakin kalau hasil ukur kita luasnya itu memang benar sampai akurasi 0,1 cm persegi. And we cannot put any figures or digits that is actually not so, how do you call it, that is actually not so justified and not so fair for us to put in. Ya, jadi nampaknya kurang adil kalau kita menuliskan angka yang sebenarnya kita juga ragu. Okay, so here is the rules that we are going to use to tackle this kind of problem. Yeah. And to make our calculation and measurement more fairly accurate, yeah, without giving any unjustified figures. Jadi ada aturan-aturan yang bakal kita gunakan agar pengukuran dan perhitungan kita itu bakal lebih akurat dan itu tuh adil, ya, tanpa memberikan angka-angka yang sebenarnya itu meragukan. So first, what we are going to learn today is how to decide or how to determine how many significant figures that exist in a set of number. Jadi yang pertama kita pelajari adalah menentukan berapa banyak angka penting dalam suatu deretan angka. And second, we will apply these rules in mathematical operation. Jadi, dan yang kedua kita bakal menerapkan aturan ini di perhitungan matematika. Let's go on with deciding how many significant figures in a set of numbers. So, speaking of figures, figures start from 0 and finish at 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We divide them into two groups. The first one, only the 0, and the second one, the non-zero. So we have the first group, the 0, that only consists of 0, and the second group is non-zero, that consists of 1, 2, 3, 4, 5, 6, 7, 8, and 10. I'm sorry, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yeah, my head a little bit messed up right now, but ya, jadi ada dua kelompok dari semua angka itu. Kelompok pertama hanya satu anggotanya 0, dan kelompok kedua anggotanya ada 9, yakni angka 1 sampai angka 9. Let's speak of non-zeros first. All non-zeros are significant. 1 significant, 2 is also significant, until 9 is significant. So if we have 23.7, 2 must be significant, 3 must be significant, and 7 too. 7 must significant too, ya. So there are 3 significant figures here. Untuk angka bukan 0, semuanya pasti penting. Jadi 23,7 itu 2-nya pasti penting, 3 pasti penting, 7-nya juga pasti penting. Jadi ada 3 angka penting di 23,7. What about 0? Well, it depends. It depends on where we put it. If we put it between non-zeros, jika kita menyimpan 0-nya itu di antara angka bukan 0, they must be significant. For example, 60.8. This 0 is put between 6 and 8. And 6 and 8 are non-zeros. 0 ini disimpan antara 6 dan 8, dan 6 dan 8 itu bukan 0. Which makes this 0 significant. Because this 0 is significant, here we have 3 significant figures. 0 ini ada di antara 6 dan 8 yang bukan 0, maka 0 ini juga penting. 6 penting, 8 penting, 0 ini penting, jadi ada 3 angka penting di 60,8. What about 2006? These 2 zeros here are put between 2 and 6. And just like 60.8, these 2 zeros are also significant. So, between 2 and 6, these 2 zeros are significant too. That means there are 4 significant figures in this number. Jadi 2 0 ini disimpan di antara 2 dan 6, 2 dan 6 itu non-zero, maka 2 0 ini juga mereka penting seperti 2 dan 6. Sehingga ada 4 angka penting di sini. Is there any other position between in the middle? Yes, at the front. 0 at the front is called leading 0. And what about leading 0? Are they significant? Leading zeros are never significant. And here's the example. 0.45. 4 and 5 are definitely significant. But because this 0 is put at the front, the 0 will never ever be significant. So there are only 2 significant figures here at this number. Karena 0 ini disimpannya di depan, maka dia tidak akan pernah jadi penting. Sehingga hanya 4 dan 5 saja yang penting. Hanya ada 2 angka penting di angka-angka ini. And we also have 0.0000207. Yeah. 2 is significant, and this 0 here at the back is also significant because we know 0 between non-zero are significant. Dan 0 di sini itu diapit antara 2 dan 7. Maka 0 di sini itu dia penting. What about the 0 here at the front? As what I have been telling you, leading 0 at the front is never significant. So the significant figures are only the 2, the 7, and the 0 between the 2 and the 7. So there are only 3 significant figures. Ya, jadi 0 yang di depan tidak akan pernah jadi penting, tetapi yang penting itu hanya 2, 7, dan 0 yang ada di tengah ini. Ya, jadi ada 3 angka penting. And we also have trailing 0. Trailing 0 is the 0 that is put at the back. Trailing 0 can be not significant. Yeah, if we don't write decimal point. For example, 7,200,000 only has 7 and 2 as significant figures. Meanwhile, the rest of the figures, they're not significant. And the reason is because there is no decimal point can be found. But we can't we write decimal point at the very back of this number? Yeah, in theory we can, but as long as the decimal point is not originally written, so these trailing zeros are not significant. Kita punya 7.200.000 dan ini ada 0 di belakang. Tapi yang signifikannya itu cuma 7 dan 2 saja karena 0 dan di belakang itu tidak signifikan, tidak penting jika tidak ada koma. Tapi kan kita bisa tulis koma di belakang. Iya sih, bisa. Hanya saja kalau ditulisnya aslinya seperti ini, maka karena tidak ada koma, 0 di belakang ini tidak penting. So there are only two significant figures. And it also happens with 80. Yeah, there is no decimal point, only 8 and 0, and this 0 is put at the back, and this 0 is a trailing 0, so only 8 which is significant, so there is only one significant figures. Can we make the trailing 0 significant? Yes, if decimal point can be found from the beginning. Yeah, 10 point something. Yeah, we don't know what follows after the decimal, but it's been written 10 point because there is a decimal point here, and it's original without us adding it. So beside 1, the 0 is also significant. So there are two significant figures. 0 ini, 10 ini, maaf, di belakangnya ada koma, dan ini komanya dari sananya. Maka dia 0 yang di belakang ini, dia itu penting, karena sudah ada koma desimal. Jadi ada dua angka penting, 1 dan 0. We also have 12.500. As we can spot here, there is a decimal point. And the decimal point here makes these two trailing 0 also significant. So 1, 2, and 5 are significant, and these two trailing 0 here are also significant because of this decimal point. So there are 5 significant figures. Karena ada koma desimal ini, maka 0 di belakang ini juga dia penting, sehingga ada 5 angka penting. The last one, powers of 10. So all figures before power of 10, they are all significant. For example, 8 times 10 to the 3. 8 must be significant, but the 10 to the 3 it's not significant. Yeah, so there is only one significant figure. Remember, the power of 10 is not significant, but the figures before it is significant. It's like what we have with 7.40 times 10 to the 4. This 10 to the 4 is not significant, but 7, 4, and 0 here at the front, they're all significant. So there are only 3 significant figures. You get it? Ya, kalau belum silakan kalian ulang videonya dari awal pembahasan tentang aturan significant figures ini. Then we'll move to the exercise. Ready? So here is the exercise for you. Please write it on your notebook and send it to me. But I'm going to put this exercise on Google Classroom. You can find it there and write the answer on your notebook as always, then upload it and submit it. Yeah, or you can simply screen capture it now. Alright, let's move on to our next discussion.